Hello everybody, I hope you're doing well and welcome to the platform of CodeChef. Today we're gonna be solving the problem divide them all. The difficulty level for this problem is cakewalk and the prerequisites required are your basic implementation. This is your educator Ansh and I hope you like my video. Let's proceed to the problem statement. Okay, now let us try and understand the problem statement, divide them all. Santa has N truffles and M candies to divide between his two buddy elves such that they both have equal amounts of total sweetness. Each truffle has a value of X and each truffle has a sweetness value of X and each candy has a sweetness value of Y. Note, a unit of truffle or a candy cannot be divided further and no item can be left out after division. Okay, so now let me just summarize what the problem statement is saying. The problem is saying that you have N truffles and you have M candies and the the sweetness value of each of my truffle or basically each truffle is nothing but X and the sweetness value of each of the candy is Y. Now I have to divide is N and M in such a way that whatever the candies I choose or basically I have to divide both of these into two categories such that whatever candies and truffles I choose, the net sweetness value of both of them should be equal to equal, right? So this is what the problem is saying. Now let me summarize the problem using this example test cases. So here I have my three truffles and here I have my two candies and I have the sweetness value of each truffle as 2 and here I have the sweetness value of each of my candy as 3, right? So how can we distribute the truffles and candy? In the first case, or basically what we can do is, we can give all my truffles, so basically 3 truffles and 0 candies to first elf, and we can give all of my 0 candies or 0 truffles and 2 candies to all of my elves. So basically what is the sweetness value here? The sweetness value is nothing but 3 into the sweetness value of each truffle, which is 3 into 2 equals to 6. And here the candies are 2 and the sweetness value of each candy is 3. So here the sweetness level is 2 into 3 which equals to 6. And since both have the same sweetness value, this distribution is possible and hence we can write yes as the answer for this particular test case. Right? Now let us understand the second test case. Here the problem is saying that we have 2 truffles and we have 0 candies. Right? So sorry, we have two truffles and 0 candies. Now the problem is saying that the sweetness value of this particular truffle is 1 and the sweetness value of this candy is 10. Right? So how we can distribute? What we can do is my candies are 0 and truffles are 2. What we can do is we can distribute 1 truffle and 0 candies and here we can distribute 1 truffle and 0 candies. And as a result the sweetness value here is 1 and this is also 1. So 1 is equals to 1 and hence the answer is yes for this particular case. So my next case you'll observe that my answer for this case will be no because no particular configuration will be possible in such a way to distribute them in two ways. So this is what the problem is saying. How can we distribute our truffles and candies into groups of 2's such that the net sweetness value of both the groups is same, right? So how can we approach this type of problem? So this problem can easily approached by a brute force algorithm. Firstly, my n in this question is as low as 10 square, which is nothing but 100. So what we can do is we can apply a time complexity of around big O of n. Okay, so what does this imply? What I can do is basically I can traverse firstly in my truffles. So I'll for I is equals to 0, my I is less than equal to n and then I plus plus. And similarly, I can traverse in my candies for my j is equals to 0, j less than equal to m, and j plus plus. Now what we'll do is, we'll try to fix the candies of I comma j as the first elf. So we'll fix the candies of I comma j belonging to elf1 and we'll fix the candies of n minus I and n minus j to the second elf. So what we're trying is, we're trying to check each and every possible distribution, which is nothing but taking a time complexity of n square, which is easily acceptable. What we'll do is, once we fix the candies for L1 as I comma j, automatically if my n candies are total and I have fixed I candies for the one person, the second candies or the candies remaining will be automatically delivered to the second person, right? So my n minus I candies will be delivered to the L2, and similarly my m minus j candies will be delivered to L2, right? So what we can do is then we can check for the sweetness value. For the sweetness value, we can easily check that my I into x plus my j into y, if at any point is equal to n minus I into x plus m minus j into y, right? So basically we're fixing I and j. Whatever candies are left, we gave it to the L2, and now we're trying to generate the sweetness value. So one candy has sweetness value x, so I candy will have sweetness value I into x. Similarly, my j into y is the sweetness value of these candies. My I into x is the sweetness value of the truffle. My n minus I is the sweetness value of the remaining truffles, and my m minus j is the sweetness value of remaining candies. And if any given instance of or any I and j, this configuration turns out to be equal, that means that that particular configuration or that particular distribution is valid, and hence we can keep a flag variable which is initially false, and if this condition is satisfied, we'll initialize our variable as true, and whenever your flag is here 1, then you'll answer yes, otherwise you'll answer no. So this becomes the approach to solve this particular problem. You'll get a complete understanding when you see the coding section. Okay, now let us try and understand the code for the following problem. Here I entered all my necessary header files. Then in my main function, I initialize all my necessary variables that I'm going to use. Then I input t as my test cases. For each of my test case, I initialize my flag as 0 as I discussed in the approach section. Now I initialize my nmxy according to the input format. Then we apply our n-square algorithm. What we do is we traverse for each of the truffles, and then we traverse for each of the candies, and then any particular point, if my n minus I into x plus m minus j into y is equals to I into x plus j into y, as we discussed in the approach section, then this distribution is valid, and I'll initialize my flag as 1. And finally, if my flag is 1, then I'll print out yes, otherwise I'll print no, right? And this becomes the approach for solving this particular problem. Now let us run our code on the sample test cases to see whether everything is working correctly or not. So as you can see, we got the exact answer according to the output format. Now let us submit our code and see whether we are getting the correct answer or not. Okay, so as you can see, we got the correct answer for the following problem, and yes, this becomes a valid approach to solve this particular problem, right? Now let us discuss what people can make mistakes in solving this particular problem. So here, the important observation was that you can simply apply a n cross m loop according to the time complexity or according to the constraints for this particular problem and easily do your code, right? So if this particular observation was clear, then I think the code is quite straightforward and there are very less chances of making mistake in this particular problem. This is the learning you get from watching my video. I hope you like this video. Please like, share and subscribe to our channel. Thank you.